Today I'm going to teach you all about the define electric current and use the equation. Okay, it's in page 77 of your Oxford Fajar book. Now let's look at this. When a wire is connected between the positive terminal and the positive terminal, this is a wire which is connected to the positive terminal and the negative terminal of a dry cell, an electric current is said to flow from the positive terminal to the negative terminal. Okay, so class, if we have a battery, a cell, a dry cell, okay, alright, so and then it's connected, say for example, to a resistor. Okay, so what happened is, this is a positive terminal of the battery, this is a negative terminal of the battery. So what happened is, current will flow, okay, from the positive terminal to the negative terminal of the battery. Current will flow in this direction. But okay, electrons will flow from this direction, from the negative terminal to the positive terminal. The flow of current is in the wire is actually due to the flow of free electrons in the opposite direction. So when it is connected, what happens is, the electron flows, the free electron flows from this direction to this direction. Due to the flow of electron, it will create the flow of current. So current will flow in the opposite direction to the flow of electron. Okay, that's what they're trying to say in this 2 points. Okay, alright. Electric current. What is electric current? Electric current, I, symbol is I, unit is ampere, is the rate of flow of electric charge. So this is called as definition. This is what? This is definition of electric current. Is the rate of flow of electric charge. Rate means is referring to time. Okay, so I is equals to dq over dt. Okay, rate of flow of electric charge. Rate means over time. Okay, if the electric current is due to the flow of free electron, then current. Okay, so here when we come back here, we just have some flashback of our prior knowledge. We remember in form 5, we remember that we studied the formula Q is equals to IT. Correct? Q is equals to what? IT. Where I is current, T is time, and Q is charge. Okay. Then we also studied Q is equals to NE. Okay. Now this N is the number of electrons. Now, if I'm not mistaken, in form 5, I think you all studied, you all put the symbol is small n. But in form 6, we're going to maintain it with capital N. Capital N is number of free electrons. I don't want to maintain it with small n because later we also have small n for some other meaning, yeah. So here Q is equals to IT, Q equals to NE. So then we get that, okay. Then here pula dia kata number of electron per second pula. Okay, now mind. So NE is equals to IT. So I is equals to NE over T. Correct? So N over T is actually, the book has given, is also capital N. Okay, the book says N over T is capital N. Okay, which is called as number of electron per second. Okay, now this one all you must know lah class, because if I put N as small n, then you will get the small n confused in the next explanation under the drift velocity, yeah. So I'm just going to maintain here with n equals to capital N over T according to the book. But you must understand. You must understand. Okay. So I is equals to N E. This N is actually referring to number of electrons per second. Okay. Alright. Alright. So that's what the book says. If the electric current is due to the flow of free electron, then current is equals to NE, where N equals to number of electrons per second. So I'm going to just like make a note here. Capital N equals to number of electrons. And there is also another capital N from another formula, which is equals to number of electrons per unit second. So you must know by formula what does that N represent, what does the other N represent. Okay, so that will be N over T, which is the number of electron per unit second. Okay, alright, so I want to take a note for 1 and 2. Okay. Alright, so again I tell you class, this capital N and small n, you really have to know how the symbol is used in the formula. What does actually it define? It doesn't define the same thing according to the formula. As we go through this chapter, you can see the difference. Alright, so that is about define electric current and use the equation. So we already defined the electric current, and now we're going to learn how to use the equation. Alright, so that is it. So now I'm going to go for my next lesson, will be explain the mechanism of conduction of electricity in metal. Actually this you have already done when you did your conduction in semester 1, but I'm just going to explain more deeper on this. Okay. Alright, so here class, okay, conduction or conduction of electricity in metal. Okay, so now here we have a wire which is fixed to a cell. Okay, and the wire is also attached to a resistor. Okay. Alright, so what happens here? We know this is a positive terminal of the battery, this is a negative terminal of the battery. We know when the switch is closed, that means the current flows. Okay, so what we're going to do is we're going to cut this certain part of the wire. This certain part of the wire I'm just going to cut, and I'm going to talk about it. Okay, so I'm going to cut, I'm going to talk about it. So it's like this. Okay, so what happened is okay, this part of this wire is fixed to a positive terminal, this part of this wire is fixed to a negative terminal, correct? So here we have a high potential, here we have a negative potential, because this one is to the negative, this one is to the positive. So here is higher potential, here is lower potential. Okay, now what happens is inside this inside this wire we have ions of the conductor. This is all metal, yeah, we have all those atoms and all that. Okay, so I'm just going to color it. These are the atoms of the wire of the metal. Okay, inside this wire also we have free electrons. Okay, we have free electrons. Now when the switch is open, okay, now I'm going to just draw here. Okay, when the switch is open like this, That means current will not flow because the switch is open. Okay, so I'm just going to take a little bit portion of this wire. I'm going to cut it off, so it will look something like that. Okay, and they have all these ions. Okay, they have all these ions, and then they also have these free electrons. Okay, alright, so these are the ions, or atoms, sorry, atoms. Okay, these are all the atoms, the molecules and so on. Okay, so what happened at this time when the switch is open? These electrons, which are called as free electrons, they move in random motion. Okay, they move in random motion. That means they move everywhere. They move in random motion. But the moment you switch close, which is this situation, and higher potential will exist at this point here, and a lower potential will exist at this point here. Okay, so that means when a potential difference is applied, okay, when a potential difference applied across length L, okay, this is the length L from here to here, okay, which is from here to here is length L, area is A. Okay, what happens is an electric field will be produced inside the wire. Okay, so I'm just going to take a different color pen. Okay, I'm just going to draw an electric field. So electric field will be from the positive terminal to the negative terminal. So the electric field will be in this direction. Okay, so when electric field is produced inside the wire, the electric field will be E equals to V over L. Correct? Now, when there is an electric field, what will happen? A force will act on the electron. A force will act on the free electron, or we say the electric field causes an electric force to act on every free electron. So there will be a force that acts on the free electron, which will be in this direction. Okay, because the electrons will proceed to the positive potential, which is the higher potential. Okay, a force will act on the free electron, where this is the free electron, this is the direction of the electric field, this will be the direction of F, this will be the positive, this one will be the negative. Okay, so this force, alright, will be F equals to QE. Okay, and F will be the resultant force, which will be equals to MA equals to QE, and A is equals to QE over M. Okay, so the electrons will be accelerated. The electrons will be accelerated okay, by the electric field. Okay, then the electrons, they will be accelerated. They also will be collide with the ions, or with the lattice of the atoms. Okay, The electron, if have acceleration, means it will have a mean velocity. A mean velocity. This mean velocity will be called as drift velocity. This drift velocity will drift the electron to the higher potential, and then it will make the electrons to flow. The flow of the electron will constitute or produce the current or create the flow of current. Okay, alright, that is the concept. Now in this part, I was telling you, there's another concept here which I'm going to write in the red pen. The electrons, when they receive, they accelerate in this direction, they will also collide with the lattice atom. When they collide with the lattice atom, some of the energy will be transferred. Energy will be transferred from the electron to the atom. Then what happens, class? The atom will vibrate faster. And when the atom or the ions vibrate faster, what will happen is heat is produced. And temperature of the conductor will increase. Now this has nothing to do with the mechanism of the conduction of electron, but I'm trying to tell you another story of what happens when the electron accelerate. So you will notice that it is also, the conduction of electricity is also related to temperature. Okay, is related to E, is related to V, is related to L, is related to F, is related to Q. What else is related? Is related to A, is related to velocity. So you will notice when you do the formula in this whole entire chapter 3, all these formulas are, all this quantity are inside the formula. Okay, so this is the mechanism of conduction of electricity. So I'm going to bring you here to your textbook. Okay, I'm going to teach you a bit more extra. There are many free electrons in metal. Okay, so this is specifically speaks about the word metal, because later we're going to look at semicon, we're going to look at insulator also. Okay, so there are many free electrons in metal. These free electrons are the charge carriers in metal. They bring charge in the metal. Okay, these free electrons are in constant random motion. Okay, now due to the random nature of motion of the electron, okay, this is very important. The mean velocity of the free electron is 0. So this process here is talking about this situation when there is no potential given to the conductor. So that says an important keyword here. The important keyword here says the mean velocity of the free electron in random motion is 0. That means without potential. So the mean velocity of the free electron in random motion is 0. Okay, then what happens? Alright, another keyword here which I'm going to look at this. The mean velocity of the free electron in random motion is 0, right? And also mean speed is in the order of magnitude 10 to the power of 6. So mean speed is of the order of magnitude 10 to the power of 6 ms negative 1. This is before you put in the potential. Okay, before. Understand? Alright, so here once when you put in the potential, when potential difference is applied, what happens? Okay, when a potential difference is applied across a piece of metal, if the free electron were to go through the same motion, its path will be B. Okay, so you will notice the path will change towards the positive potential. First it was the path A, right? Then it will be towards the positive potential. So the electrons, the free electron will be drifted towards the positive potential. The free electron, being negatively charged, drifts, you see the word drifts, towards the end of higher potential. This flow of free electron constitutes an electric current. So this portion here talks about when you apply a potential difference. Okay, when you apply a potential difference. And what happens in this part here is that you will have the drift velocity, which I'm going to talk in the next point. Okay, the concept of drift velocity. Alright, so this is about my lesson today. And that's all, class. Thank you.